So this is the 55th video on Newton's laws of motion. This is in continuation of the 54th video. Okay. So in this video, I'll take up a numerical problem on Newton's second law of motion, similar to the problem which was discussed in the 54th video. Okay. So again, in this problem, I'll apply a constraint relation in which there are variable angles in the problem. So again, constraint relation for displacement and velocity will have the same format, but that of acceleration will be different from that of velocity and displacement. So first I draw the diagram of the problem. Okay. This is the problem. This is the wedge, say of mass 2m. This angle is 60 degree. Here we have block of mass m. Here we have a fixed massless pulley attached to the wedge rigidly. This is a string. This string passes over this pulley and this passes over another pulley. This is a fixed vertical wall. And string comes here like this. See. Now there is no friction anywhere. This is the horizontal surface. This is the inclined face of the wedge. The block is free to slide on the inclined face of the wedge. Mass of wedge is 2m. Wedge is denoted by W. M is denoted by B. This is the string. String is massless and inextensible, and there is no friction anywhere between string and pulley in contact. And this pulley is rigidly fixed to the wedge. Okay. And there is a fixed vertical wall. This pulley is also fixed to the vertical wall by means of this rod. And this string passes over the pulley. It is in contact with the wedge here. Question is, now this angle initially is theta naught. Let us say 45 degrees, say it is given. This angle also 45 degree, it is given, theta naught. Okay, alright. Now question is, when the system is released from rest, then find the acceleration of wedge W with respect to ground at an arbitrary instant t after the beginning of motion. After beginning of motion. Also find the initial value of A. Also find initial acceleration of initial value of AWG. Initial value of AWG. AWG meaning what? Acceleration of wedge with respect to ground. Okay. Also find the initial value of AWG. AWG meaning acceleration of wedge with respect to ground. Initial instant when theta naught is 45 degree. Now first of all you must note, see, when the system is released from rest, this block will slide down the wedge and this wedge will move rightward. Okay. As the blocks and wedge will move, this angle, these two angles will change with time. But they will always remain equal because of geometry. But they will change. These two angles will not remain always 45 degree. They will change with time. These two angles will change with time. Alright. So there are variable angles in the problem. So again, constraint relation for displacement and velocity will have the same format, but that of velocity and acceleration will not have the same format. So let us assume that after the start of motion, t seconds later, the situation is something like this. This is the situation at time 0, but situation at time t I'll draw here. So this is the wedge C. I've decreased the size of the wedge just to fit in the problem. So this 2m, alright. This is 60 degree, alright. See, like this. Like this, see. This is some instant t, alright. So now suppose at this instant t, acceleration of wedge with respect to ground is A rightward and acceleration of block with respect to wedge is B. Also, velocity of wedge with respect to ground is VWG and velocity of block with respect to wedge is VBW. And suppose the displacement of wedge with respect to ground is dx in time t to t plus dt, and displacement of block with respect to wedge is dl in time t to t plus dt. Now one more thing, the string is massless and there is no friction between string and pulley anywhere. So tension at all points of the string is same, say equal to T. This T is at a given instant, time instant, okay? So now, first what we'll do, this problem will be similar to that in the 54th video, okay? See why I'm taking such kind of problems. I'm taking so that you become familiar with the concept involved, it becomes thorough. Okay, it is very essential that you solve such kinds of problems. Then only you're going to get some speed while solving problems with J Advance. Otherwise, you don't think by trying simple objective questions, you're not going to gain that confidence. So you have to try to solve as many problems as you can. That is going to benefit, you're going to benefit from it. Okay. So now, first I write down, apply the Newton's law to this block with respect to wedge down the incline. So first what I do, I write down I draw the free body of block with respect to wedge. Okay. So if you draw the free body of block with respect to wedge, then real forces will act. What are the real forces? Mg, T, N, and A is in that direction. So pseudo force becomes this way because wedge is translating an IRF. Okay. Now I write down the Newton's second law equation of block with respect to wedge down the incline. Down the incline component Mg becomes Mg sin 60 degree. Mg root 3 by 2 plus Ma cos 60 degree plus Ma by 2 minus T is equal to Mb, first equation. First equation I have already obtained. Fine, alright. So these are a bit now. So this equation I substitute here. Mg root 3 by 2 plus Ma by 2 minus T barabar Mb. This is the first equation which I have written here. So this I rub it now. Okay, fine. Now what I'll do, I'll write down at time t this angle is theta, this angle is also theta. They are always equal by geometry, but they vary with time. Now at time t, we have to rewrite down the combined equation of wedge plus block in rightward direction. As I've discussed in the 19th video on Newton's laws of motion, combined equation is always written with respect to ground frame, and only real external forces appear in the combined equation. So first, to write down the combined equation, I draw the free body of block and wedge separately with respect to ground. Okay. In this, only real forces will appear. No pseudo forces. So see, this is a block of mass m. This is mg. This is t. This is n. No pseudo force acts on the block as seen from ground frame. Now I draw the free body of wedge with respect to ground. So like this. Here we have 2 mg, weight of the wedge. Then there is normal force on the wedge due to ground N1. Then the block exerts normal force N on the wedge in accordance with Newton's third law. Now one more thing, this is the pulley. This pulley is rigidly fixed to the wedge. The tension will act on it at 2 points. At this point and this point. This angle is theta. And tension also acts on the wedge at this point. T. This angle is also theta. Okay. So these are the forces which I have shown just now. Okay. Now, in the system of wedge plus block, which are the internal forces? This T and T are internal force, they go away. This N and this N, they are internal forces, they go away. Only what external forces are there? T, T, 2mg, N1, mg. Now we are writing on the combined equation of the wedge plus block in this direction. So only T cos theta plus T cos theta, they are the only components which appear. These are all right angles, they do not have any component in that direction. So, what do we get? We get this T cos theta plus T cos theta. 2t cos theta is equal to 2ma plus m times, what do we write here? X component of acceleration of block with respect to ground. So we write like this, ABG x. What does that mean? X component of acceleration of block with respect to ground. X component of acceleration of block with respect to ground. Okay, fine. So what do we get here? 2t cos theta is just equal to 2ma plus, we express this as a dot product. This becomes abg dot I hat. So we get 2t cos theta is equal to 2ma plus n times abg dot I hat. This becomes abw plus awg dot I hat. Okay. So this becomes, now I have this one. Okay, fine. So now simplify this. 2t cos theta is equal to 2ma plus m times. What about ABW? It is nothing but acceleration of block with respect to wedge. We simply vector B. AW is AWG, acceleration of wedge with respect to ground. That is simply vector A dot I hat. So we get 2t cos theta is equal to 2ma plus, I'll break this from distributive law. I hat is unit vector along this direction, which I call as x axis, okay? So this I hat is what? B dot I hat plus A dot I hat. So it becomes 2t cos theta is equal to 2ma plus m times, what about B dot I hat? B is in this way, I hat is that way, angle is 120 degree. So this becomes B into 1 into cos 120, which is minus half. And A dot I hat becomes what? A dot I hat becomes A into 1 into cos 0 degree. Cos 0 degree becomes 1. So we get what? 2t cos theta is equal to 2ma plus ma, 3ma minus mb by 2. This is the second equation. And this is the first equation. Alright, fine. Now I love this one, okay? So what we get here? We get 2t cos theta is just equal to 3ma minus mb by 2. This is the second equation which we obtained, okay? Now I love this one. Now we need the relationship between B and A, constraint relation. A constraint relation again, as I said just now. In this problem there are variable angle, this angle, these two angles change with time. So constraint relation for displacement velocity will have the same format, but that of velocity and acceleration will not have the same format. So first what do, I write down the constraint relation for displacement. That is work done by string on all bodies in contact with it adds up to 0 in any frame of reference. So I apply the constraint relation for displacement in the frame of wedge. Okay. In ground also you can write it. You can write in any frame of reference. It is true in any frame. Because length of string is constant in any frame of reference. Okay. Length of string is constant in any frame of what? Reference. So you can write in any frame. So I am writing down in the wedge frame. This is the wedge frame of wedge. So constraint relation in the wedge frame. So imagine that in time t to t plus dt, wedge gets displaced with respect to ground by amount dx and block gets displaced by amount dl. This is the displacement of block with respect to wedge in time t to t plus dt, and dx is the displacement of wedge with respect to ground in time t to t plus dt. Dx is in this direction, dl is down the incline. Now see, this is the string. So string, total work done by string on all bodies in contact with it is 0. Now this string will exert force on which points? This string will exert a force on the wedge at this point. Then will exert force on this pulley at effectively 2 points. At this point and at this point, T and T. Then this string will exert force on this pulley at effectively 2 points. One at this point T, one at this point T. Then this string will exert a force on this block in where? T up the incline. Alright, fine. Alright. So now I write down the constraint relation in frame of the wedge. So work done by string on the wedge in wedge frame. In the frame of wedge, this point has 0 displacement. So string does 0 work on wedge in the frame of wedge. So T into 0. Okay. Now see pulley. Now we have to find the work done by string on the pulley in the frame of wedge. Now see, in the frame of ground, pulley is fixed. This pulley. And in ground frame, this wedge is moving rightward dx by amount dx. In the frame of dx, 2m, sorry, in the frame of 2m, this pulley will move left by an amount dx. Is it alright? In frame of ground, 2m gets displaced by dx, rightward. And this is at rest with respect to ground. In the frame of wedge, this pulley will appear to move leftward by an amount dx. Okay? So T will act here and this point gets displaced dx leftward with respect to wedge. And this point also gets displaced by dx leftward with respect to wedge. And T acts in this way. And this angle both are theta by alternate angles. This is not theta, not but theta, because I am writing at arbitrary instant, not tan 0. So it will be how much? 2t, t dx cos theta plus t dx cos theta. 2t dx cos theta. Okay, fine. Now work done by string on the pulley in the frame of wedge. That will again be 0. Because string is acting on the pulley at effectively 2 points. This force and this point. These 2 points are rest with respect to wedge. So t into 0 plus t into 0. T into 0 plus t into 0. Okay. Now you take this block. T acts on this block up the incline. With respect to h, it gets displaced by dl. So T is up, dl is down, angle is 180 degree. Work done becomes T dl cos 180 degree, which is -1. They add up to how much? 0. All this 0 goes away. So what do we get? 2t cos theta dx equal to T dl. Now T goes away. What do we get? TL equal to 2 dx into cos theta. Okay. So this is the constant relation for displacement. Now what we do? We divide these quantities by dt on both sides. dl by dt becomes 2 dx by dt into what? Cos theta. Now dl by dt is what? There is nothing but displacement velocity of block with respect to h, VBW. Now I have this top portion, okay? So what do we get? This dl by dt becomes what? VBW, velocity of block with respect to wedge, is equal to 2 dx by dt. Dx by dt becomes what? Displacement of wedge with respect to ground. That is VWG into cos theta. See, this is the constant relation for velocity. This is the constant relation for displacement. They have the same format. Just replace dl by VBW and dx by VWG. And cos theta becomes cos theta remains. So they again have the same format. But we are not interested in velocities, we are interested in accelerations. So what to find the acceleration, what I do? I differentiate this equation with respect to time. Again, okay. So I differentiate this equation with respect to time. So what do we get? dvw by dt becomes d by dt of 2vwg into cos theta. Okay. Now this becomes derivative of vbw with respect to time, becomes acceleration of block with respect to edge, which is simply b. Now this I differentiate using product rule of calculus. 2 comes outside. This becomes 2v dvwg by dt into cos theta plus 2vwg d by dt of what? Cos theta. Fine. All right. Now rub this one. So what do we get? B is equal to 2. dvwg by dt is nothing but a acceleration of wedge with respect to ground. 2a cos theta, and this I differentiate using the product rule of calculus, chain rule. It becomes d by d theta into cos theta into d theta by dt. So this becomes b is equal to 2a cos theta, d by d theta of cos theta becomes minus sin theta, and this becomes omega, angular speed of this string at time t with respect to ground. So it becomes 2vwg minus sin theta into omega. See, this is the third equation. Okay. So you see, the constant relation for acceleration does not have the same format as that of velocity and displacement. So this is the constant relation. I will write it here. So what do we get here? B is equal to 2a cos theta minus 2 omega vwg sin theta. This is the third equation. Okay. Now we are asked to find the value of a at arbitrary instant. Alright. Write up this one. Fine. All right. Now what I'll do, I'll replace b here, put this b here, and from this t I'll put it here. Okay. So this t replaced by t. What do we get? T becomes how much? mg root 3 by 2 plus ma by 2 minus mv. This becomes t. See, t becomes this much. mg root 3 by 2 plus ma by 2 minus mv. This t I put in the second equation. So 2 times t cos theta. T becomes this. mg root 3 by 2 mv by 2 minus ma by 2 minus mv into cos theta. 2t cos theta, t I have substituted here. That is nothing but 3 ma minus mb by 2. Alright, fine. Here, this t I have found from this and substituted this t in here. Alright. Now I take a and b on right side. So if I multiply this, the 2 to go away. mg root 3 into cos theta. Fine. mg root 3 into cos theta. So this becomes how much? 3 ma minus mb by 2. And these two terms come on right side. Plus 2 cos theta. Minus ma cos theta. 2 into 2 goes away. Ma that side. Minus ma cos theta. Alright, fine. Now m will go away, common term. So what do we get? G root 3 into cos theta is equal to 3a minus b by 2 plus 2b cos theta minus a cos theta. Alright, fine. Now what I do, I replace this b, I put in this. G root 3 cos theta is equal to. So this becomes b, I'll take common, and 3a minus a cos theta, I'll put it together. 3a minus a cos theta, fine. Plus 2 cos theta minus half, okay, into b. This b will not fit here, I'll write it below. I'll grab this, okay, and write it below here, I'll write. Plus, this is the right side. So this becomes 2 cos theta, and this becomes how much? 2 cos theta minus half. 2 cos theta minus half, okay. And b, what about b I'll write? So b I'll write this. 2a cos theta minus 2 omega VWG sin theta. Sin theta, okay. Fine, alright. So now I'll write this one, alright. So now I'll simplify this for a. So what do we get? I bring this term left side, this omega VWG sin theta, I bring it to this side. So it becomes how much? G root 3 cos theta, huh? And I bring this term left side. So plus 2 omega VWG sin theta. Sin theta. 2 cos theta minus half. Upon is equal to, sorry, equal to how much? A is common here. 3 minus cos theta. And A is common here also. This 2 I'll put inside this. 4 cos theta minus 1 into cos theta. See, I suppose it is alright. This 2 I multiply this 2 to 4 cos theta minus 1 into cos theta. I hope it is fine. Alright. 2 I will 4 cos theta minus 1 into cos theta. Okay. So how much A becomes? G root 3 cos theta plus 2 omega VWG sin theta. 2 cos theta minus 1 half upon 3 minus cos theta plus 4 cos square theta minus 4 cos theta is the required value of A. First answer has been obtained. Fine. Alright. Is it alright? Fine. Now rub that side, okay? So now if we simplify, this becomes 5 cos theta. So A becomes G root 3 cos theta. G root 3 cos theta minus plus 2 omega VWG sin theta into 2 cos theta minus half upon 4 cos square theta minus 5 cos theta plus 3. Okay. So this is the answer, first answer to first part of question. Also, we have been asked to find the initial value of A when the system is just released from rest. When the system is just released from rest, then omega and VWG are both 0. So they will go away. The initial value of A just after system is released from rest. Just after the system is from rest, that is omega 0 and VWG also 0. So this term will go away. What do we get in that case? And theta becomes theta naught, 45 degree. Theta replaced by theta naught, 45 degree. That becomes g root 3 into cos 45 degree, which is 1 by root 2. This becomes 4 cos square 45 degree, 4 by 2, minus 5 by root 2, plus 3. Okay? This becomes how much? G root 3. This becomes 2 plus 3, 5 minus 5 by root 2. 4 by 2, 2, 2 plus 3, 5, 5 minus 5 by root 2, root 2 multiply. So 5 root 2 minus 5. This is therefore the required answer. See, this is the initial value of acceleration of the wedge with respect to ground. G root 3 by 5 root 2 minus 5. 4 by 2 becomes 2, 2 plus 3, 5, 5 minus 5 by root 2 multiply here, 5 root 2 minus 5. This is the required answer. Okay. So again I have taken this problem also and I have solved it fully. So you go through it properly. In case you have some doubt, again write in the comment box, I'll clarify it. But again, one thing I am saying, if you are not able to understand such questions, you go through these videos repeatedly again and again. Then it will become clear to you. Okay? But still, if you have some doubt, you write in the comment box, I'll clarify it. You must definitely solve such kinds of problems. It strengthens your concept. It increases your confidence, accuracy and speed. So you must definitely solve, because see, in JEE Advanced they can ask anything. And I'm telling you one thing, they say, I think they are claiming that it's JEE Advanced is objective. I don't think it's objective in any way. You have to solve around 16 problems in 17 problems in 1 hour. And problems are not that simple that you can just write down the answer and get away. No. Considerable amount of effort and intelligence is required. So you have to solve such kinds of problems. There's no way out. I don't think so. Okay. So next video also I'll make some more problems of different type. Okay. I close it here. Fine.